This video is all about the exact trigonometric values. So if you know these, you will be able to do trigonometry without a calculator. You need to know them for the angles of 30, 45, 60 and 90 degrees. So for example, you need to know that sine 60 is root 3 over 2. You need to know that cos 45 is root 2 over 2. You need to know that tan 45 is 1, and so on. You need to know all of this information. Now, when I was at school, I was told just to learn all of this. Just learn this table, is what I was told. However, I don't like that method. I am definitely an advocate of trying to remember as little as possible and being able to work out as much as possible. So rather than learning all of this, I want to show you a way that you can work it out with as little memory as possible. So, all you actually need to know are these two triangles. That's it. As long as you can do Pythagoras, which you all can do, and as long as you can do SOHCAHTOA, which you all can do, you can work everything in this table out from these two triangles, and I'm going to show you how, which is much better to learn just two triangles and figure the rest out for yourselves than trying to learn all of that information. So let's start off with the isosceles right angle triangle. So it's a right angle triangle here, and it's isosceles because these two sides are the same. If it's isosceles and that's 90, that means that these two angles are both going to be 45. So here is my isosceles right angle triangle, and I'm going to show you how that allows us to know what sine 45, cos 45 and tan 45 are. So I've got my 45-degree angle here. I'd like to know these sides, however. So I'm just going to pick a number, and I'm going to pick, let's try and make this as simple as possible. So let's say that this side length is 1. Just keep it as simple as possible. So that's why I've done 1. If this side length is 1, then this has to be 1 as well, if it's an isosceles triangle. Now doing some Pythagoras, 1 squared plus 1 squared. So 1 plus 1 is 2. Square root that is root 2. So the hypotenuse of this triangle is root 2. Right, sine 45. Sine is the opposite divided by the hypotenuse. So the opposite of this angle is 1. The hypotenuse of this triangle is root 2. So sine 45 is 1 over root 2, which if we rationalise that, if we times top and bottom by root 2, we get root 2 over 2. Right, cos 45. Cos is the adjacent divided by the hypotenuse. So that's 1 over root 2 as well. And if we do the same thing as what we just did above, we get root 2 over root 2. And finally, tan 45. So that's the opposite divided by the adjacent. So 1 divided by 1 is 1. And so we can see clearly now where this column came from. What about the other angles? What about our 60 degrees and the 30 degrees? Well, that's going to come from the other triangle, the equilateral triangle. So, if it's an equilateral triangle, I know that this is 60, this would be 60, and this would be 60. Now, in order for me to actually do some SOHCAHTOA with this, I need this to be a right angle triangle. So what I'm actually going to do is I'm going to split this triangle in two, like that. I'm going to split it in two, so I've got a right angle here now. So this triangle here is like that. Now, in order for me to do some SOHCAHTOA with this, I'd like to know the side lengths. So, just like in the last one, I can pick the lengths of the sides. So I could say that this is going to be 1, this is going to be 1, and this is going to be 1. I'm not actually going to do that, however, because remember that I split this triangle in 2. And if I split that in 2, then I'm going to end up with an awkward fraction here. So instead of saying 1, 1, 1, I'm going to say 2, 2, 2. And that's helpful because then when I split this triangle in 2, I know that this length is 2 and that length there is just 1 now because it's 1 here. I can now do some Pythagoras to work out this length here. So the hypotenuse, so 2 squared is 4, 1 squared is 1. To work out this shorter length here, I'm going to take those away. So 4 take away 1 is 3 and square rooted. Right, I've got all my side lengths, so I can now work out these missing these ratios. Sine 60, I know that opposite divided by the hypotenuse. So root 3 over 2. Cos 60, I know that's adjacent over hypotenuse. Tan 60, I know that's opposite divided by the adjacent. And root 3 divided by 1 is just root 3. So we've done 45-degree angles, we've done 60-degree angle. What about the 30-degree angle? Well, in actual fact, I don't need to do any new triangles because I know that that angle there is 30 degrees. And I know that because it was 60 to begin with. And if I split that 60-degree angle in 2, I know that's 30 and that's 30. So that's 30 here. So that allows me to now work out the trigonometric ratios for 30 degrees because sine 30, so if I'm talking about the angle 30 here, the opposite side to that is 1. So sine 30 is 1 over 2. Cos 30 is the adjacent divided by the hypotenuse. And tan 30 is the opposite divided by the adjacent. And if we rationalise that, if we times top and bottom by root 3, we get 1 times root 3 is root 3, and root 3 times root 3 is 3. And there we go. These are the other two columns. So this column is there, this column is there. So I've shown you where all of these values in this table come from. And we don't need to learn any of it. All we actually need are these two triangles, a little bit of Pythagoras and a little bit of SOHCAHTOA. That's all you need to be able to get these values.